In this lecture, we are going to solve an example of Newton-Raphson method. For nonlinear equations. All right. So before doing so, I'm going to overview the steps for Newton-Raphson method. First, we choose initial values x, 0. So why do we call them values? Because x could be vector of variables, x1, x sub 2, and x sub n. The second step, we determine the Jacobian matrix and its inverse. So Jacobian matrix at the current iteration, we call it iteration k inverse. The third step, we find the step to update variables. So delta x at iteration k is equal to minus the inverse of Jacobian matrix at the current iteration multiplied by value of your function evaluated at xk. The next step is updating variables using step 3. So delta x at iteration k means the difference between iteration k plus 1 and iteration k. So the value of your variables at iteration k plus 1 is equal to the value of the variables at iteration k plus delta x at iteration k. This fifth step is termination criteria. So termination criteria tells us if y evaluated at the new updated value of x at iteration k plus 1 is less than epsilon. This is a small value that you set to make sure your problem is converging. Yes. So if so, you stop, and xk plus 1 is the solution to the equation system. Else, if not, you go to step 2 and update step 2 and start finding the Jacobian matrix again and update your variables until you converge. So now let's get into our example. Our example is find the solution to this set of equations. x1 squared. So let's call this f1 of x sub 1 and x sub 2. x1 squared plus x2 squared minus 5x1 plus 1 and f sub 2 x1 x2 x1 squared minus x sub 2 squared minus 3 x sub 2 minus 3. This is equal to 0. This is equal to 0. So sometimes to be consistent, they also give you the starting point. So the initial guess or the value of your variables at iteration 0, which is x1 at iteration 0, x2 at iteration 0, is equal to 3, 3. So I'm just going to provide one iteration to give you an idea of how to calculate it when you have a case which is not one-dimensional. So the first step is Let's go back to the previous slide. As you see here, the first step is to choose initial values, but this is already done. So we go to the second step, which is find the Jacobian matrix. So this is step 1. Step 2 is find Jacobian matrix. So the Jacobian matrix in this case, we have two variables and we have f1 and f2. So it's going to be derivative of f1, partial derivative of f1 with respect to x1, with respect to x2, f2 with respect to x1, and f2 with respect to x2. So now we are going to look at our functions and find these derivatives. So f1 with respect to x1 is going to be 2x1 minus 5. With respect to x2 is going to be 2 multiplied by x sub 2. f2 with respect to x1, 2x1 and f2 with respect to x2 is going to be minus 2 x sub 2 minus 3. All right. Now what we are going to do, first we are going to evaluate the Jacobian at x in the iteration 0. So Jacobian of x sub 1 and x sub 2 evaluated as at x0 is 1, 6, 6, minus 9. How do we find this? x1 is 3, x2 is 3. So this is going to be 2 multiplied by 3, which is 6, minus 5 is 1. 2 multiplied by 3 is 6, 2 multiplied by 3 is 6, minus 2 multiplied by 3, minus 6, minus 3, minus 9. So now what we are going to do, we are going to find the inverse of this Jacobian. Before doing that, let me review the inverse for a generic 2 by 2 matrix. So let's call our 2 by 2 matrix A, B, C, D. Inverse of this matrix is 1 over AD minus BC. Then we change the location of the diagonal elements and we multiply the other two elements by minus 1. So this is the general rule to find the inverse for a 2 by 2 matrix. If it's larger scale problem, basically you will use some programming languages like Python or MATLAB to find this inverse. So let's go back to our problem, which was 1, 6, 6, minus 9 inverse. And this is our Jacobian inverse. So 1 divided by minus 9 minus 36. We change the location of these two and we multiply this by minus 1. It's going to be minus 9, 1, minus 6, minus 6. So if we simplify this further, it's going to be 1 divided by 5, 2 divided by 15, 2 divided by 15, and minus 1 divided by 45. So this is our Jacobian inverse. Let's go back to the previous slide and see what's the next step. So we did this one. The next step is to find the updates. So we did step 2. The third step is to find updates using this. All right, so step 3. Delta x at iteration 1 is equal to minus Jacobian inverse evaluated at x0 multiplied by y, or f1 and f2 evaluated at x0. All right, so if we want to evaluate y, we already have this. This is our Jacobian matrix inverse. We want to find the value of y at x0. x0 is both of x's are 3. So if we do that, the first one is 9 plus 9, 18, minus 15, 3, plus 1, 4. F sub 2 is 3, 3, 3. Is 9 minus 9, 0, minus 9 minus 3, minus 12. All right, so we simply have to multiply the Jacobian inverse, minus 1 divided by 45, by the values of F1 and F2, which are 4 and minus 12. So if you calculate this value, this gives you x1 minus x0, or it gives you x at iteration 1 minus 3 and 3. So in the first step, what you are going to do, you are going to find the value of x at iteration 1, which is 3, 3, plus delta x at iteration 1. And this one gives you the new updated variables. After this step, you're going to evaluate the value of your objective function given the new values for x's and see if it meets your criteria. So in the fifth step, you have to define epsilon. Sometimes you can define epsilon to be 0.01. Sometimes it's given in the question, so maybe they want more accuracy, so it's 0.001, and so on. So this was just an example of the iterative process for Newton-Raphson. If you want to show this like a flow chart, this is going to be like this. Yes, x at iteration 0. Find Jacobian matrix and its inverse. The next step, find the delta x, or the update for your variables at iteration k. Then you update the variables xk plus 1 is xk plus delta xk. The next step, it's checking the convergence criteria. If y k plus 1 is less than epsilon. Y evaluated at x k plus 1 is less than epsilon. If yes, then stop, and x k plus 1 is the answer. If no, what will happen? We go to step 2. So this is the flow chart for Newton-Raphson method.